Okay, welcome to the new lecture. In this particular lecture, we will be working with missing data in pandas. So in pandas, missing data occurs when some values are missing or not collected properly, and these missing values are represented as none. So we can use the none to represent a missing value, and we can also use the not allocated value, a special floating point value from NumPy, which is recognized by all systems that use IEEE floating point standards. So in order to check whether you have a missing value in your pandas data frame, we have basically two methods. The first method is null method, and the second one is an a method. So first, talking about the is null method, so it returns a data frame of boolean value where true represents missing data, and this is simple if you want to find and fill missing values in a data set. So in order to do that, first we have to import the libraries of pandas as pd and numpy as numpy. Okay, so uh, first we will create a dictionary. We have created a lot of dictionary just for the demo purposes, so that we could then transform this dictionary into the pandas data frame. Here you can see that we have intentionally inserted not allocated values, but this not allocated value is inserted here with the help of the numpy library. You can also use something like none, so both of them works exactly the same, but this particular not allocated value from the numpy package is a standard that is used widely throughout the world and across different platforms as well. So once we convert this dictionary into data frame, then we will first display it, and then we will create a new object of the pandas data frame. So we will be calling the isNull method with the help of the original data frame, and then we will find out that where are the missing values in the resultant data frame. So now after executing this code, we can see that this is the original data frame. So we have three columns here. So here we have inserted not allocated values with the help of the none keyword, with the help of here. So this particular not allocated value is inserted with the help of the none keyword, and the rest of the two not allocated values are inserted with the help of the numpy attribute. Okay, so when we call the isNull method using the data frame object, it basically returns a data frame of a boolean value which represents missing data. So this method will return a boolean data frame in which each of the value will be represented either with the true or false. If it is false, then it means that it does not contain any missing value, but if it returns true, then it means that this particular value is missing here. So that is why missing value object contains the boolean value instead of the original values. Similarly, let's import the employees.csv file, which already contains some missing values. So then first we will display the last five rows of this particular data set, and then we will check that if the gender column of this particular data set contains any missing values. So what it will do is that it will create a boolean series for that particular column within this data set, and then we will use that column as a filter, and then we will insert that filter into the original data frame. As a result, it will give us the new data frame in which the gender column will contain only those values or those rows that do not have the gender value inserted. So you can see that this is the original data frame in which these are the last five rows of this particular data set because of the tail function or tail method, you can say. And then what we have done is that we have created a Boolean series in which the gender is false or true, and then we have inserted this particular Boolean series into the missing gender, incorporated into the original data frame. And what we have done is that we have tried to interpret to the Python interpreter that only show me or return me the data frame that contains those rows in which the gender value is not inserted. So the resultant data frame with the name missing gender data contains only those rows that contains only the rows in which the gender column does not have any value inserted. So if I want to convert this into the head, even in that case we will see only those rows that will contain only the not allocated value. So eventually it does not mean that this particular object has some rows that contains the non-missing values or in which there are some values. In fact, this particular data frame now contains all the rows and all the data that has only those rows that contains the gender value having the missing value. So instead, if I remove this head or tail, then we will see the all of the data. This all data contains, you can see that there is no such row that contains the some value here. All of the values under the gender column has not allocated values. Okay. The second method to find out if the value is inserted or not in a particular cell of the table is the is and a method. So is and a method also returns a data frame of the Boolean values where true indicate missing data. It is used to detect missing values just like is null. So eventually both of them having the same function. So again we have created a dictionary here in which we have intentionally inserted the non-allocated values. Then we will display the original data frame, and then after displaying the original data frame, what we are doing is to display the a data frame in the form of the Boolean values where the true value will dictate that this particular here value is missing, and if the value is not missing then it will simply return a false. So this is basically an alternate option of the uh, is null. You have both options. You can use is null or is na. Both works exactly the same. So checking for non-missing values using the not null. So not null works somehow the opposite of the is null. That is, it will return those values as true if it is not null, and if it is null then it will return false. So both of the concepts are contradictory to each other. In fact, this not null also returns a data frame, but in that particular data frame, if the value is missing, then it will show us the false here instead of the true. I hope you got the point here, so there is no need to explain it in much detail, so we will skip it and then move to the next one. So here what we are doing is that we are again importing the employees.csv dataset, and within that dataset we are basically you can say that returning a series in which the gender column values are replaced with the true or false values. So if it contains any value instead of a missing value, then it will be, you can see we are applying sort of a filter here. So we are applying a filter on this particular data frame that only return those rows or an object of the data frame that contain only those rows in which there is some value inserted in the gender column. So in that case, this is the opposite of the previous one. In that case, that we will see only the data frame having rows in which the gender column is not missing. So this is the resultant value. So you can see that now there will be no such row that contains a missing value. All of the rows under the gender columns have either male value or female value. So this is the second option. And filling missing values in Panda. So what we can do is that let's suppose we have a missing value. So what you want to do is that you want to fill it with some default value, and we can define based on our need that what that default value can be. So as an example, again, first we have created a data frame from a dictionary in which we have purposely inserted some missing values, and then we will be first displaying that you can save the original data frame. So here you can see a missing value, here is a missing value, and here is a missing value. So now what we are telling our interpreter that if there is a missing value, then what you can do is that you have to fill that missing value with a exactly 0. So after calling that particular method, this data frame will be transformed, or it will return a data from that is the transform data frame in which the missing values be replaced exactly with the 0 value. So here you can see that 0 value, 0 value, and 0 value. So you can achieve such kind of data frame with the help of the fill na. And this one is a little bit interesting, that if you want to fill the missing values with the previous value. So the previous value means that I think there should be an example here. Okay, so it means that we are filling we are calling the same function fill na, but instead of uh, passing some constant argument here, what we are doing is that we are using a parameter that is the named method, and this is equal to padding. So padding means that if we have a missing value, okay, and as an example there was a missing value here. So this is so let's first display let me display the original data frame. So this is the original data frame, and here in the original data frame we can see that there are missing values here, here, and here. So if you use an argument that is pad, it means that you want to fill the the current value with the previous value. So as an example, the previous value for this missing value is 90. So what it will do is that it will exactly copy the value of 90 here as well. So as an example, you can see now this missing value is filled with the previous value, that is 90. Similarly, there is a missing value here. So the previous value for that missing value is 56.0. So that is why we can also see that there is a value 50 exactly 56 here as well. Now this is a special case because it does not have a previous value here. So that is why the interpreter cannot replace it with the previous value, and you will see exactly the missing value here as it is. So in order to resolve this particular situation, what you can do, you can use the backward fill as well. So this, in this case we are using the argument backfill. So it will what it will do is that, again, let me just display the original data frame. So this is the original data frame. So first we can see that there is a missing value here, here, and here. So the backfill means that replace it with the next value instead of the previous value. So this missing value will be replaced with 95, and this missing value will be replaced with the 41. But again, in that case, since it does not have the next value, so that is why this missing value will be as it is in the resultant data frame. So that is why we can see that this not allocated value is same as in the original data frame, and it did not replace it with any value because it does not has the next value. So in case if you want to resolve this issue, so after first calling the previous value, next value, then you can again apply a function of the fill na with the pad argument. So in that case, this particular value will be replaced with the 56.0. Okay, what if you want to replace, you can say that some missing value with a particular value, that is the no gender. So again, in that case, what you are doing is that you are importing the data from a particular file, and now what we are doing here is that we are displaying the range of rows with over choice. Instead of using the head or tail methods, what we are doing is that we are asking our method, our interpreter, to please display me the row number 19 to row number 23. So first let me just you can say that display the data. So you can see that since we asked to show me the range of the rows, so that is why you can see that row number 19 up to the row number 22. So it means that if you use uh, such kind of rate, then 23 is not included. Instead, it will show us the range of rows one less than 22, that is the 22, that 23, that is the 22. So you can see these four here, and here you can see that there are some rows in which the gender value is missing. So here is a missing value and here is a missing value. So what you can do is that you can ask the compiler, sorry, you can ask the interpreter that, look, I want the gender column to be filled with no gender. Okay, and in place is equal to true. It means that I want to modify the original data frame. In that case, this original data frame will be updated, in which all the missing values under the gender column will be replaced with the no gender. And again, just for the sake of ease, we want to display the row index number 19 up to the row index number 22. Remember that 23 is not included in that range. So that is why now you can see that first we can see that only row number 19 up to 22 are visible in the output, and where there were missing values under the gender column have been replaced with the no gender, which we explicitly specified here as an argument. So this was yet another way to tackle with the missing value. And there is yet another method with the name replace. So what you can do is that you can use the replace method, and again there is a parameter with the name to underscore replace is equal to np dot not a missing value, and you want to replace all those missing values with the value minus 99, which you can use as a default value. So if I execute that code, then all the missing values in the whole data set that is represented in the pandas data frame form, you can see that there was a missing values here. It was replaced with the minus 99, minus 99, minus 99, similarly minus 99. So all those were missing values that have been replaced with the default value. So now there is yet another method with the name interpolate. So again, we have created a data frame with the help of the dictionary, and then first we want to display that particular dictionary. So now you can see that this dictionary contains some missing values here, here, and here, here, and here. And then interpolate the missing values in the linear method. This method ignores the index and consider the values are equally split. So if you are familiar with the stats, so this interpolate name is basically kind of a technique in the stats in which you want to replace the missing values with some periodic values. So if I use this interpolate method, and specifically I want to choose the linear method and limit direction is forward, then you can see that this data frame in which there was a missing value between the range of value 1 and 5, so it will sort of select a value that is in between that range. And again there was a missing value between the 16 and 3, then it will be replaced with the value of 9.5. Similarly, there are two values missing between 6 and 3, then it will accordingly adjust the missing values with the 4 and 5 as well. Okay, so again you can play much around with it if you are familiar with the interpolate function, that is basically taken from the statistics. So dropping rows with at least one null. So this is again how to tackle with the missing value. So you can also drop at least one null value. So if in case if you don't want any kind of row that has at least even one null value, that you can particularly drop that particular row from your table. So in that case we can see that we have created a dictionary and then converted that dictionary into the data frame. So then you have converted that frame. So here we can see that there is only so first let me display this data frame here. So here you can see that uh, there is only one such row that does not contain any missing value. So if you want to use drop NA, what it will do is that it will drop all those rows that contains even a single missing value. As an example, this row contains a missing value here, this row contains two missing values here, and this row also contains two missing value here, but this row does not contain any missing values. So after using the drop any, it will return a data frame object that will contain only that row that does not have any missing value. So this is the resultant data frame in which you can see that there was a row with the index number 3, and this particular row does not contain any missing value as well. So in case where you want to drop rows with all null values and you don't want to drop a row that has contains one or more null values, but not all values are null. So in that particular case, again let me display the original data frame. So you can see that this particular original data frame, there is a row here in which all the values are null. So if you want to get rid of this, then you can use argument here how is equal to null in the drop NA method. So it will drop only that row that it does not contain any value, and all the values are missing here. So the resultant data frame, you can see that row index number 1 is has been dropped or deleted from the data frame as well. So dropping columns with at least one null value. So here we were talking about the dropping values in terms of the row. Now here we want to drop a column that contains at least one missing value. So again let's take a look of the original data frame. So here this column contains two missing values, this column contains one, this column contains one, but this column does not contain any missing value. So again you have to use a drop NA method. So instead of access equal to 0, you have to use access is equal to 1. So what it will do is that it will drop all those columns that contains even a single missing value. So as a result, you can see the resultant data frame contains the column that does not contain any missing values. So you can use same sort of uh, same sort of methodology by importing a file, by importing the data from a file. So in that case, instead of using a dummy data set, we have imported our data set employees.cfe and converted into the pandas data frame. And then what we have done is that we are using a drop na function, and then we have applied x is equal to 0. So by applying x is equal to 0 means that we are applying this uh, the drop na method over the row wise instead of the column wise. And then what we are doing is that we have used an argument any. So it means that it will drop all those rows in which even a single value is missing. So it means that the old data frame contained thousand rows in which there were, you can say, about 236 such rows that contains even a single missing value, and there were 764 such rows that did not contain any missing value. So this is it from the pandas data frame, in which the first we learned how to detect the missing values and how to tackle with that missing value as well. Thank you for watching. See you in the next lecture.